Hello, everyone. My name is Andrew Pippo, and for the final project, I'll be going over what Kotlin is alongside what coroutines are and how coroutines are used in modern programming, to write better applications, better code, everything to the extent. So real quickly, what Kotlin is, it's a more modern programming language that is open source, statically typed. It works and targets JVM, Android, JavaScript, WASM, and native. It is a object-oriented programming language. However, it does have some functional constructs, so you may consider it a functional programming language in some regard. And what's unique is that it is very much similar to Java. It operates similarly with its behavior, its execution, and basically is essentially intertwined, especially with the syntax being very similar. And you can basically swap Java code with Kotlin, converted, especially in an IDE like Android Studio. And Kotlin is basically more concise, more type safe. It allows smart casting, higher order functions, and extension functions and lambdas compared to other programming languages. Since this is a lot more modern, it picks up what those older programming languages lack, making it a better, more effective language to where it does not cause as many issues when it comes to an execution. Um, Generally, it is used for Android development. And if you go on Google's website, they're starting to promote this a lot more. But since it is similarly to how Java is, or even like C++ or other languages, you can use it for like native development, website development, multi-platforms, desktop, and even server side. Since the syntax is very similar to how the behaviors act, everything like that. But Kotlin tends to be better in those regards than compared to Java, especially with like build checking as well, for example. What coroutines are is that they are a program component that allows executions of code to be suspended and resumed, and they're basically these subroutines for multitasking. And these are not specific to a programming language. However, I'm just going to show it in Kotlin for this video. Conceptually, it acts like a thread. These coroutines, it basically runs as if it is a thread. However, it is not attached to a specific thread, as this code is actually run asynchronously, um, as it allows a management of like long tasks. And say if you have like one task going on at the same time as another, one of those tasks would be running in the background while the other's on the main thread. That way, it prevents the application from being blocked on the main thread, and it prevents it from being unresponsive and essentially crashing or causing some weird behavior or bugs. And these coroutines are designed to be lightweight. They minimize the memory leaks, and it does contain the cancellation support, so you can actually suspend or stop these functionalities without causing issues for the main functionality of the program. And to demonstrate that here real quick, I do have a little bit of an Android application pulled up to where this is a stopwatch app. And not only will it have it display the timer or stopwatch, there is a 1 second simulated extra task that I will show running on both the thread and in the background. So to show it with it running on the main thread, so if you hit the start button, you can see it will pop up the time. And as it did that, it ran this 1 second simulated code to where it returns a random value. And it also displays the time it took. So if you go in here, you can see that it printed out that it took 1.052 seconds. And it basically, since it was attached to the thread, it actually caused a little bit of strain on the main thread. And you noticed that as it was trying to display, there was a little bit of a lag there. And basically, if this was like long enough, it could cause unresponsiveness to an app that was trying to run two tasks, where you need the time showing up and something else going on, or something like that. And then the coroutines is executed by the second stop button, and it's using the asynchronous, it's using the suspension. And basically, if you run this, you can see that it takes a little bit less time, but it does in fact not skip as many frames, and it's basically not as extruding on the main thread. and it's not as extruding in terms of the time it takes. It actually is quicker. And if you notice, I have ran this a few other times um, before, and it does show the similar trend of it running faster, and it's not as basically present on the main thread. And in practical sense, you would use this for any applications, websites, anything that to where you would have a main task going on, but you need something else going on in the background, whether that's updating values or just have like multiple things displaying at the same time, anything like that. And even this application, the two timers are running on coroutines so that they can both display at the same time. So that will in fact do it for my presentation. I hope everyone has a great day.